In this example, we'll find the interval and radius of convergence for the given series. Now, remember that if we can write this as something raised to the k power, we can use the root test and we're happy. But in this case we can't do that because there's this k squared doesn't have a k as an exponent. This has a 2k as an exponent and there's no exponent at all down on this one. Which means that we're left to use the ratio test rather than the root test. So we need ak plus 1 over ak in absolute value. And then we'll take the limit of that as k goes to infinity. A k plus 1 means plug k plus 1 in for k, so that's k plus 1 squared. X plus 3 to the 2k plus 1. Watch your parentheses. It's not 2k plus 1 outside of the parentheses. The whole k plus 1 becomes, the whole k becomes k plus 1. That's over k plus 1 factorial. We're dividing by this. If we're dividing by this, that's the same as multiplying by the reciprocal. So that's times k factorial over k squared x plus 3 to the 2k. And we do need our absolute values. And then we're asking ourselves what can simplify. From here to here, we've seen this before in previous examples, in previous sections. K factorial and k plus 1 factorial. Well, k plus 1 factorial is k plus 1 times k factorial. Right? 10 factorial is 10 times 9 factorial. So we can take off the first term and then the rest of them become factorial. And we do that so that we can cancel this. So that's going to leave us with a k plus 1 in the denominator right there. I can't do anything with the k plus 1 squared and the k squared until we get to the limit part. Well, let's write it out as it is anyway. K plus 1 squared, k squared. So now I do see that there's something we can do because these will match up. And we'll do that in the next step. So now we've taken care of this. We've taken care of this. We don't have to worry about those anymore. The only thing that's left to worry about that I haven't looked at is the x terms. There's 2k of them downstairs, and there's 2k plus 2 of them upstairs. So 2k plus 2, which means there's 2 more copies upstairs than there are downstairs. So we really are left with an x plus 3 squared. Now I can cancel the k plus 1, and that leaves me k plus 1, x plus 3 squared over k. And really we still have our absolute values. That's fine, we've done a lot of work to get there, but we're not near done yet. We've got to take the limit as k goes to infinity. As k goes to infinity, the k plus 1 and the k are the biggest degree terms. K plus 1 over k is 1. So in the limit, as k goes to infinity, this stuff goes to 1, and we're really just left with x plus 3 squared in absolute value, but since it's squared, it's already positive. And the final limit is just x plus 3 squared. Which means that we need, remember that when we apply the ratio test, that final limit that we get, we need to be less than 1. So we're looking at x plus 3 squared less than 1. I can take the square root of both sides. That's still okay. That works just fine. That's x plus 3 is less than 1, which is negative 1 is less than x plus 3 is less than 1. Subtract 3, and I get negative 4 is less than x is less than negative 2. What does that mean? That means that the radius of convergence, now we have to be a little bit careful because we're not centered at 0 anymore, right? We're actually centered at negative 3. Negative 3 is the middle right in here, which shouldn't be too surprising because we've actually shifted everything to the left 3 units by using an x plus 3. Negative 3 is the middle. How far do we go in either direction? We go 1 this way, we go 1 this way, so that the radius of convergence is 1. If you were to graph negative 4 to negative 2, you'd find that you're moving 1 unit away from the middle. And that's what it means to have the radius. So that's fine, but we still do need to check the endpoints. So we're looking at -4 less than x less than -2, but we do need to check those endpoints. So let's let x equal to -4. If x is -4, this becomes sum k squared. -4 plus 3 is -1, so that's -1 to the 2k over k factorial. -1 to the 2k is always -1 to an even power, so that's sum of k squared over k factorial. We could go through the whole ratio test again and figure out what happens. Take me at my word for it, this one converges. K factorial goes to infinity so much faster than k squared that this series does in fact converge. But if you would like to test it, or if you're asked to test it, then you would apply the ratio test again to this specific series and find that it converges. If x is equal to -2, then we get sum of k squared. -2 plus 3 is 1 to the 2k over k factorial, which is the same series, k squared over k factorial, which still converges. Which means testing both of those endpoints explicitly gets me a convergent series. So really we get -4 less than or equal to x less than or equal to -2. And the interval of convergence includes both endpoints.